Alright guys, so today we're gonna do something about the AMC 12A. The competition is just on the last Wednesday. Yep, last Wednesday. So today I'm gonna do 3 questions about the AMC 12A and hope you guys understand it and to get a better score on the AMC 12B. Alright, let's see the first question. The question 5 because I picked some random questions from the AMC 12 and I hope you guys better understand it. So question 5, in the figure below, the outside square contains infinitely many squares, each of them with the same center and size parallel to the outside square. The ratio of the side length of the square to the side length of the next inner square is k, where k greater than 0 and less than 1. The spaces between squares are alternately shaded as shown in the figure. The area of the shaded portion of the figure is 64% of the area of the original square. What is the value of k? So we go from the question. We know the ratio of the side length of a square to the side length of next inner square is k, which means if I set the side length of the biggest one as a1, and the next one should be a2. And the ratio of the side length should be a1 to ratio to a2. It should be equals to k. And the area a1 over a2 equals to k squared. So that's the first step we could get. It probably doesn't mean something, but we have to write them down to make sure we focus on the question. The area of shaded portion of the figure is 64% of the area of original square. It means a shaded area over a whole area, which is a1, equals to 64%. So a shaded area it's a infinite geometric series, because it's an the question said it contains infinitely many squares, so it's an infinite geometric series. So we have to know the formula for the sum of a geometric series, which is the sum equals to the first term a1 over 1 plus common ratio. Common ratio is basically k squared, because the area of the outside one over inside one is k squared. So that's a common ratio for square. So we know this formula and this formula, so we can get it. The a shaded. This one is just for a shaded. It's a1 over 1 plus k squared. So just plug a shaded to this one. It goes to a1 over a plus k squared times the reciprocal of the a1 equals to 64%. A1 cancels out. 1 over k plus 1 over 1 plus k squared equals 64%. And you go for the steps. 1 over 64% equals to 1 plus k squared. 64% is 100 over 60, 64 over 100. So reciprocal of 64% should be 100 over 64 equals to 1 plus k squared. Minus 1, 64, 100 minus 64 is 36 equals to k squared. So k equals to 6 over 8. We simplify it, it's 3 over 4. So the answer is D. Alright, let's see this next question. In a certain alien world, the maximum running speed v of an organism is dependent on its number of toes and number of eyes. Toes is n, eyes is m. The relationship can be expressed as velocity equals to k constant times n raised to a power of a and m raised to power of b. Centimeters per hour, where k A and B are integer constants. Okay, they're integer constants. In a population where all organisms have 5 toes, which is n equals to 5, the log base 10 v equals to 4 plus 2 log m. And in a population where all organisms have 25 eyes, which is m is 25, log v equals to 4 plus 4 log n, where the logarithms are base 10. What is the value of k plus a plus b? So this one is pretty tricky. So basically from the question, we know the relationship of velocity can be expressed as v equals to k times n raised to the power of a and n raised to the power of b. So what I'm gonna do, so we take the log base 10 for both sides. Log v equals to log k n raised to the power of a times m raised power of b. And based on the product rule of the logarithm, we can do log k plus log n raised to the power of a and plus log n raised to the power of b. And we can further simplify it by using the exponential rule for the logarithm. So it's log k plus a times log n plus b times log m. So let's see the first situation where n equals to 5. So log v equals to 4 plus 2 log m. So log v equals to 4 plus 2 log m. So we see it's here's a log m and here's another log m. So the coefficient is 2 and the coefficient is b. So we easily get b equals to 2. All right. So the second situation, log v equals to 4 plus 4 log n. It's 4 times log n, which is here. The coefficient is a, so a is 4. Okay. So we know a is 4, b is 2. So the relationship can be expressed as v equals to k times n raised to the power 4 times m squared. That's super clear. And then if we plug the n, whereas the organism have 5 toes, to the relationship, what we can get is, we should simplify the log first. So log v equals to 4 plus 2 log m. For this one, we take the inverse function, which is raise them to power of 10. We got its v equals to so it's a log 10 raised to 4, and we take it's a log 10 raised to 4, which is 4. So this one is, so it equals to log v equals to log 10 raised to 4 plus log m squared, and equals to log m 10 raised to the power 4 times m squared. So v equals to 10 raised to the power 4 times m squared. So v equals to, and that's the stuff we already know. So v equals to 10 raised to the power 4 times m squared. It's for the first situation where the organism have 5 toes. So toes represents n, so n equals to 2. And we see two equations, they both have velocity. We can get it, we solve the system equation. So 2 raised to the power 4 times k times m squared equals to 10 raised to the power 4 times m squared. M squared cancel out. So k equals to 10 raised to the power 4 divided by 2. Oh, I mean it's 5. It's 5. 5 raised to the power 4. So it goes to 2 raised to the power 4, and it's 16. So k is 16, a is 4, b is 2. The value is 16 plus 4 plus 2 is 22. The answer is C. Let's see the next question. In a pentagon ABCDAE, it's inscribed in a circle. So in a circle, and we just draw a random pentagon ABCDE. So A, B, C, D, E. Or A, B, C, D, E. And BEC, the measure of angle BEC, BEC equals to angle CED. So this angle equals to this angle is 30 degrees. And let AC and segment AC and BD intersect at point F. AC and BD. Is and BD intersects at point IF. Suppose that AB is equals to 9 and AD equals to 24. 24. What is the length of BF? This one. Alright, this one's pretty tricky, but it's pretty easy to solve if you know some geometry knowledge about the circle. So in the geometry knowledge, based on the knowledge we know, so if the arc, the corresponding to the angle in the circle, which is BEC, should be equals to the same angle as the same arc corresponds to. So the arc BC corresponds to the angle of BEC. This one, this arc, and D corresponds to BAC as well. This one. Alright, I'm doing it in red to make sure it's really, to make sure it's more significant to see. This angle, BAC and BEC. They correspond to the same arc, which means they are in the same angle degree, which is 30 degrees. Let's see the next one. So the arc CD, it corresponding to the CED. CED, or this one, right? And it also corresponds to the CAD. This one, right? So this one is 30 degrees as well. So AC should be the angle bisector for the AC is angle bisector of angle BAD. So this question becomes pretty straightforward if you know the angle on the angle bisector theorem. So the angle bisector theorem basically means if here's a triangle, you have an angle bisector. You have an angle bisector here. So the ratio of AB and AC equals the ratio of BD and CD. But before that, before we use the angle bisector theorem, we have to know the length of BD. So we know the angle BAD it certainly becomes 30 degree plus 30 degree. It becomes to 60 degree. So we know the length of AB and length of AD. So we use the law of cosine, which is BD squared equals to AB squared plus AD squared and minus a half times cosine 60 degree times AB times AD. So BD squared equals to 9 squared plus 24 squared minus a half, and cosine 60 degree, they got cancelled out, minus 9 times 24. So 9 squared is 81 plus 24 squared, we just, it's 16, 9, 8, 4, so it's 576 plus 81, it becomes to 7, 5, 6, 6, 657 minus 9 times 24 minus 216, so it's 143. 341, I guess it's a BD square. So BD should equals to 21, I think. No, hold on. Should be 21. Yes, I think it's 21. Wait, hold on, no. Should be wait. Oh, it's 4. It's 441. So it's 21. Yeah, it's 21. Pretty straightforward. It's 21. So BD is 21. And we assume that BF is X. So FD is 21 minus X. Based on the angle bisector theorem, we know 9 to 24 equals to X over 21 minus X. So 9 times 21X, 21 minus X equals to 24X. 21 times 9 is 189 minus 9X equals 24X. So 36X equals to 189. So X equals to 36 over 189. We divide by 3, it's 12 over 63. We divide by 12, we divide by 3, it's 20. Wait, hold on, my bad. It's my bad. So X equals to 189 over 16, over 36. We divide by 3, it's 12 over 63. We divide by 3, it's 21 over 4. Wait. That's interesting. I think did I miss something? Yeah, it's 33x, because it's 24 plus 9x. So we divide by 3, it's 63 over 11. So we got E for this one.